Okay, here's a Mathematica file that I used to solve the two-link plunger. The first couple of lines are taken from the download that you can have. I always like to quit when I start Mathematica files, just in case I've been running something before. This next one is how you define your I, J, and K vectors. That's just the way it's done. Okay, so now the next thing is to I'm just defining cosine of theta and sine of theta in a convenient way so that it's easier to type. So CT and ST are cosine and sine of theta, as you can see here. And then the next thing that I do after you want to do it on paper so that you know what your equations look like and what's needed. So the next thing that I do is I like to define the terms that are known. So for example, there's point D, C, and B, and you know what those velocities are. And so I like to put it in here. Now, one thing that's important is recognize that when you say 0, the velocity of D is 0. You want to make sure that it knows it as a vector, and so you want to say 0 times I, or 0 times j, or 0 times k, something that uses a vector so it knows that it's actually a vector, not just a number. Same thing with velocity of b. If you notice here, the velocity of b is also specified as a vector. Then down at the bottom, I don't know why I put them in that order, velocity of c, you don't know anything about it. It's got an x piece in the I and it's got a y piece in the j. Here's the R from D to C, and here's R from B to C, and then you have your omegas, omega 1 and omega 2. Just make sure everything's a vector, and then I'll execute that so it knows what those are. And then here are the special point equations. There's 2 of them. So you have a set of equations, that's why you have the curly brace. And then you just type them in. Velocity of C is equal to the velocity of D plus the cross product of omega and R. Make sure you put the order in properly. It's the first vector goes in and then the second vector. If you do it backwards, R, D to C, comma, ohm 2, you're going to get the negative of that. So it's always omega cross R, omega cross R. Okay. So I just typed in those equations and then we'll just execute those. And it prints out the equations. And what I like to do is just make sure that if you're doing 2 dimensions, all of the z components should be 0. So I just kind of it's a quick check and make sure that all the z components are 0. All right. So the first term here, for example, that's the I piece. Then you have the comma, and then here comes the j piece, right, and a comma, and then the k piece. So I just look in those and kind of the sanity check, make sure everything is okay, and then you want to solve the equations. And in this case, you want to solve for theta dot VCX and VCY. So if you hit execute, it comes up and solves them for you fairly quickly. Here is the theta dot that we solved for by hand, and you can see it's exactly the same thing that you had before. It likes to use cosecants and stuff. Anyway, so after you solve the velocity equation, one of the things that you need is the angular velocities. And so I just, all I did was I copied and pasted. So I just went like this, highlight the thing that I want, and I copy, and then I pasted it in down here. So this is the solution that you get from the velocity. Okay, and then I just mimic it. So what I'm going to do is I'm going to just kind of scroll up so you can see how I'm mimicking what I did here. I said I knew the velocity of D, and so I do the same thing down here. Acceleration of D is 0. I know the velocity of B, and so down here I know the acceleration of B. Up here was the R's. You don't really need to repeat them because they're exactly the same, but I did anyway. The next thing is omega of 1. This is going to be alpha, the angular acceleration of 1. So you can see, all I did was I put in a dd. So this is theta double dot. That's what I mean by that. And then you have the alpha of 2, similar to the omega, right? So here's the alpha of 2, theta double dot instead of just theta dot. And then the acceleration of c, I knew nothing about the velocity, well I still don't know anything about the acceleration. So those are basically mimicked off of that. Your acceleration equations, you had 2 velocities, so you'll have 2 accelerations. And so here they are. Acceleration of c equals acceleration of b. Instead of this one is cross alpha cross r. And then you have the, you could say minus omega squared, but I find it, since, I mean, I wouldn't want to do 2 cross products, but Mathematica can do it quick. So I find it easier to just say cross omega r. Okay, so that's the, I'm not using the simplified formula, it's the whole thing. And then you have a comma and you put in your second equation here. Okay, and then you just execute that one. And, oops, I already did that one, I think. All right, and so we'll execute and define the acceleration equations. And then just like before, you solve this time I'm going to solve the acceleration equations and not the velocities. Just like before, I solved for velocity of c in the x, velocity of c in the y, and theta dot. This time I'm mimicking it. I'm solving for the acceleration of c in the x, acceleration of c in the y, and the theta double dot. And so when you execute that one, you end up with the answer here, and here's your theta double dot, which is what I was really looking for. So that guy right there is the theta double dot, and that's going to be exactly the same as what you had from hand. Okay, so that's how you would use Mathematica to solve this.